Alright, let's get started on the practice problem on Canvas. The first question is, consider an assembly line that has 20 stations. Each station has a 0.5% probability of making a defect at the end of the line. An inspection step singles out the defective unit. The inspection step catches 80% of all defects. From inspection units, whatever units are deemed to be non-defective are moved to the shipping department. I probably did not finish the question. I should have said the one which are deemed defective are sent for rework. Sent for rework. The first question asks, what is the likelihood that the unit ends up in the rework? Well, first we need to find out what percentage of the units are good or what units are defective. Well, the easiest way to do this is find out the yield of the process first. That's easier because there are 20 steps and we know the yield of each step 0.5%. If we know the yield of each step is 0.5%, what is the yield of the process? Well, the yield of the process is this is the defective rate, so the yield is 0.995 because 99.5% is same as 0.995. So the yield of each step is 0.995. So if we have the yield of each step, we can find the yield of the process. The yield of the process thus is 0.9046. If we know the process is making this many good parts, we know it's making 1 minus 0.9046, which is 0.0954 defective parts. Well, we got something, but that's not what we asked. The question is, what is the likelihood it ends up on rework? Well, that is how many are caught. Well, we know 80% of the defect are caught. Well, that means out of the 0.0954, 80% is caught and goes to the rework. So that is 0.0763%. So 0.63. So that is the percentage is 7.63% of the total items has to go to the rework, right? The next question was, what is the likelihood the defective unit is shipped? So that means out of the 100 items that we work on, how many is shipped defective? First, we know that we produce altogether 0.0954, that is 9.54% is defective parts. Out of that, we catch 80%. We catch 80% and send them to rework. That means we don't catch 20%. That means we don't catch 0.0954 times 0.2, that is 0.0191. That means we ship 1.91% of items as a defective unit. It was easy. Alright, the next question is, in this hospital, the upper specification limit is 0.55, the lower specification limit is 0.45, and the standard deviation is 0.02. The question asks, what is the CP? Well, CP is upper specification limit minus lower specification limit divided by 6 sigma. Well, the upper specification limit is 0.55, the lower specification limit is 0.45, divided by 6 times 0.02 comes out to be 0.833. Well, the next question is, what percentage of the series is outside the specification limit? Well, this takes us back to the previous chapter where we have the mean. The mean is said to be 0.5. The mean is 0.5. The upper is 0.55. The lower is 0.45. The question is, what is right of 0.55 and what is left of 0.45? Well, we need to find the parallel of this in the standard normal what is the equivalent of 0.45 and what is the equivalent of 0.55? Well, to do that, let's call this G1, let's call this G2. To find Z1, all we need the equivalent of 0.45, so 0.45 minus the mean 0.5. Well, the standard deviation here is 0.02 divided by 0.02 gives us 0.05 divided by 0.02 comes out to be minus 2.5. Similarly, we can calculate G2. G2 is the equivalent of 0.55, so 0.55 minus 0.5 divided by 0.02 comes out to be 2.5. So we know this is 2.5 and we know this is minus 2.5. Then all we gotta do is go to the G table and find out the equivalent value of minus 2.5, which happens to be 0.0062. That means 0.0062% portion of the items lie left to it, and given that this is symmetric, exactly 0.0062 is right of it. So altogether 0.0062 times 2%. There's a probability that this much items lie outside the limits, so it comes out to be 0.0124, which is same as saying 1.24% is item lie outside these limits. The next question was, well, suppose the company wants the CP to be 4 by 3rd. How do we get there? Well, now the company wants the CP to be 4/3. Well, the formula for CP is upper specification limit minus lower specification limit divided by 6 sigma. Well, I want the CP to be 4/3. Upper specification limit was 0.55. Lower specification limit was 0.45. 6. I want to find the sigma, or cross multiplication. 24 sigma equals to, this is 0.1 times 3, or sigma equals to 0.3 divided by 24, which happens to be well, I think I had the answer ready somewhere. Maybe not. All right, 0.3 divided by 24 equals to 0.0125. So my standard deviation needs to be 0.0125 instead of 0.2, so that I can have the CP of 4/3.